in this video, we're going to be reviewing questions for tomorrow's test. Feel free to skip ahead and pause as much as you feel you need to. If you have any questions, just message me on Remind or email me and I'll try to get back to you before tomorrow. We'll go ahead and get started. Let's look at this first question here. It says properties of logarithms for number 1 and 2 in the practice packet I gave out Friday. This is, on this first one, when we're expanding, we are trying to get it to look sort of like what number 2 looks like. We're doing the opposite of number 2. And we have these properties here. So product property, quotient property, and power property. So whenever we are expanding, we're going to start with usually one of these two properties, the quotient or the product. But in this case, we have a special opportunity to use the power property. So look what's happening. We take the power here and we move it to the front of the logarithm itself. So what that's going to look like on this one, I'm going to take this 3 and it's going to get moved to the front. So I'm going to put this right here. So this is 3 log, that in parentheses, a to the third over b. And so that'd be the first step in this process. And this is, of course, the red is our final answer. So let's talk about what we do next. Going back to our rules, we're going to be using the quotient property. Look, we have a fraction, and we're going to break it apart into 2 logarithms separated by subtraction. That is the quotient property. So let's go ahead and show that. This is going to change into this. I keep the 3 in both of these. So it's 3 log. Now, order does matter. This a to the third is going to start here. Okay. And then the division symbol becomes subtraction. And I repeat the logarithm. It's 3 log b. Okay, now the last part, you're probably wondering, well, how did it get to this? Well, we can use that power rule again right here, how it's in the exponent, and move it to the front. And that's what happens with this 3 right here. So that's going to move to the front again, and it gets multiplied by that one. So it's 3 times 3 log a minus 3 log b. And that's 3 times 3 is 9, so that's how we get to our final answer right here. Now let's look at number 2. Number 2, we condense. So we're making it, we're going to make this one look like number 1 originally was, with a few different properties. So when you're condensing, the first thing you want to do is you want to use this power property. Now for this one, we're already in this format, so we're going to take the in and go the other direction. We're going to put it into the power. Let's do that. This 3 is going to go to the power here. The 6 is going to go to the power here. So this is going to be log base 9. We always keep the bases the same, by the way. We don't change them. Of 10 to the third. This plus sign, we'll keep that for now. And then this one over here is log base 9, 11 of 6. So that would be the main first step here. We're moving these powers up here to the front, or to the top of these, from the front to the top. Now we get to use the last rule that we haven't used yet, which we're in this format here. It's separated. Now to combine them, we're just going to multiply the numbers that are here. So I'm going to take log base 9 of 10 to the third plus log base 9 of 11 to the 6th, and we're going to make one single logarithm that the two values, this one and this one, are now being multiplied here and here. Okay, on to the next part. So this one here, the amount of money, this is number 3. The amount of money in a bank account can be expressed by the exponential equation a equals 300 times 1.005 to the 12t, where a is the amount in dollars and t is the time in years. About how many years will it take for the amount in the account to be more than 900? So in this one, we're not having to set up an equation or anything. All we're going to do is we are going to use our calculator to answer this question. So I'm going to take my equation, 300 parentheses 1.005. We're going to raise that to the 12t. Well, and instead of t, we need to put in a number of years. How many years will it take for the amount in the account to be more than 900? Well, let's start with maybe 5. And we can see that, well, that's not when it's 900. Let me go back up. You can go back up and copy and we just go back and we're going to edit this 5. Let's make it a 10, see what that does. Still not enough. Let's go back. Edit the 10, let's make it a 15. Still not enough. Again, copy. Let's try 20. I did too much. Okay. And that might be too high. It's over 900, but we might need to go back and check when is it first beyond 900. So let's try 19. You can see that's 935, which 19 is the answer on this one, as we can see over here in red. But what happens when I put 18? So let's do that. And you can see that 18 is below 900. Now there's another way we could do this, but for the simplicity of it, that's the best way to do it, is just sort of plugging in years until you get more than 900. That's all it really wants in this case. Okay, so let's continue with number 4. On number 4, we are taking logarithms and exponential functions and or equations and switching them into the different form. So we need this equation here is going to help us. B to the x equals a. You can go between the forms like this. Log b of a equals x. Okay, so all I'm doing is here, this is b, this is a, this is x, and that's how I got into this form here, b to the x equals a. Okay, so that's why that is the answer. I just moved the numbers. So pretty simple and not a lot of work that's involved on that one. Let me go back here. This is b, this is x, this is a, looking at our form up here. So I put b here, a here, and x here. That's all you have to do on number 4 and number 5. Okay. Let's look at number 5 now. Solve the equation. We have our answer over here. We are going to need our calculator again for this. But we are again trying to solve for an exponent. So this is x, this is b, and this is a. And if I'm using what we just did on 4 and 5, b to the x equals a, because here's where we apply it, I'm going to have to use this logarithm to solve this. So I want to go ahead and switch this to logarithmic form from exponential to logarithmic. The problem is this 3 is in the way. So how we deal with that is we're going to do a little bit of algebra. I'm going to divide a 3 from both sides. So I get rid of this. 8.7 divided by 3. So I'm going to go ahead and use my calculator to help me out. Division, and we get 2.9. 7.6x. Now we're going to turn it into a logarithm. So I'm going to do that over here. So I have space. So log, this is b again, the e is b, to the 2.9, 7.x, or 7.6x, sorry. There's our function. Now we're going to type this in over here. So to get logarithm, control 10 to the x. The e is in the pi button here. So e to the 2.9 here. So I get 1.06471. We're just round that to 3 places. Should be good enough. So I'm going to do 1.064 equals 7.6x. So now all we have to do is divide this 7.6 from both sides. Goes away. We're left with our final answer, x equals. So we're going to divide that by 7.6. That's how we get our answer right here. Okay. And moving on, number 6. Let's make this large again. Number 6. So we're going to solve this. Here we're solving exponentials. The last topic was solving exponentials, and we could use the logarithm to help us. But on number 6, we actually can't use a logarithm because both sides have variables in them. Okay. So what I'm going to do is I need to get the bases of these to be exactly the same. So I need to think of another number to where I can make the base equal the base over here. So right away, when I see a 36, that makes me think, oh, well, 6 squared equals 36. So I'm interested if 6 to any power would equal 216. So I'm going to grab my calculator. Let's try 6 to the third. And we can see, okay, that's 216. So over here, I'm going to do 6 to the third equals 216. Over here, the reason I'm doing this is because I want to get the same bases. And you can see these 6's will be the same base. I'm going to replace the 36 with a 6 to the second power. That 2n is still out there. Over here, it's going to be 6 to the third power. Yep, in 3 minus n. This is the main step on this, is getting these same bases. Because when I have same bases, we can focus on the exponents. So with these exponents, though, before we get rid of our bases, we need to multiply these. So I'll show that like this. 6 to the 2 times 2n, so that is 4n for that exponent. Over here, it's 6 to the 3 times 3 minus n. Well, I have to distribute this to all of it. I can't just do to one, I have to do to both. So this is 6 to the 3, well, excuse me. 3 times 3 is 9 minus 3n. This is where I want to be, because once I get here, I'm able to forget about these bases and really just focus on the exponents. 9 minus 3n equals 4n. So what I'm going to do is just solve for n. I'm going to add 3n to both sides. Goes away. I get 9 equals 7n. Last thing I'm doing is dividing by 7. Goes away. We get 9 over 7 n, which is what the answer was. Okay. All right. Next, number 7. So here we're transforming functions, and this right here would be called the parent function. And we do the transformations to parent functions. It's the one that we start with. So what I did was, you'll notice we subtracted 3 from here. Okay. And this part of the function is responsible for the horizontal shift. Okay. And if we are subtracting, it goes to the right. Okay. If we're adding, it goes to the left. So over here, you can see we did right 3 units because it said minus 3. Okay. That's why we went to the right. So it's sort of opposite of what you think. Next, so that is right here. Okay. Next, we look at this. This is going to be responsible for vertical shifts. If it's positive, it goes up. If it's negative, it goes down. Okay. So in this case, we have a positive value there. It's added, so it goes up. So this is going with that one. Okay. The last thing that happens is we go from having a positive here to a negative right here. Okay. What that does is it causes a shift, or excuse me, not a shift, a reflection over the x-axis. Anytime you change that sign that's in the front, it reflects over the x-axis. So that's the explanation for this one. And these are the 3 main things that are going to happen on our test, is you're looking for those different types of shifts. And we have horizontal from this, vertical from this, being on the outside here. And reflection is that. The next question is asking you to take what we just discussed in number 7. So number 8, and look at number 9. We're using the same idea. So we have our parent function here, and they're saying it's transformed 6 units to the right. So this is, it's whatever is happening to this value here. Okay, so that's why we chose that as our answer, or for our answer, as to the right. Horizontal shifts are when you're subtracting from the x value. And then reflections, well, that means that we have to make it a negative. And it's always reflected about the x-axis. Okay? So that's why we got that answer. Everything about this original function stays the same except for these 2 things here. Okay? Let's go to number 10 now. That says if you deposit $5,000 into an account paying 4.25% annual interest rate compounded continuously, so that's important, how much will there be in the account after 4 years? So this function right here is what we're going to be using. That's the formula that you need for continuous compound interest. This E value is something that you can get in your calculator. The first thing we're going to notice is that this 5,000, that is your principal, that's P, here is your rate, R, but we have to make sure that we say that R is in decimal, so it's 0.0425, and you'll see that in our function below here. And then T is time right here, which is unknown right now. So there's really only two things that we need to know to get this answered. This will always have E. When it says continuously, we use the Euler's constant. Then all you have to do after you get your function created from this step is plug in a 4 right here, and you can see it in the calculator. Let me show you how you type this in the calculator. So I do 5,000. To get the E, you can go here and click that one. That's fine. Or you can just hit this e to the x button right here, and you can type in 0.0425, and we want to multiply that times 4. And there it is. That's how we get our answer there. Let's go to number 11 now. Number 11, you buy a car for $32,300. It depreciates at an annual rate of 8.3% compounded monthly. So this, we've got all the information we need there. Write a function that represents the value of the car over time. So we're just writing the equation. Here is our formula for compound interest. R is going to be the rate. We saw that in the last question. So that is 8.3%. So we use 0.083%, or a decimal right there. Compounded monthly, that is going to be your N value, how many times you compound. So that's 12 in this case, and that's going here and here. That's always going to be the how many times it's compounded. And in the last example, continuous, we just go with the E, so we don't have to worry about it. But this is what we put there and there. This is R. We'll talk about the negative in a second. P is this right here, your principal, which I need to edit really quick. Type in how much it actually is, which is 3.2. Okay, that's the cost. Okay. Drawing tool. So this is P right here, which we found there. Now the negative, because it says the word depreciates right here, that is that's what we're going to be using the negative for. So this means negative. Okay, so that's why we're looking at that. So this is the function. This is all we needed to do on this one. So this is R. This is it. Got my values sort of shifted, but so there's our answer for that one. Let's look at number 12. So this is the geometric series question. This is what you're going to be looking at. It says a post is driven into the ground. The first strike drives the post 25 inches into the ground. So we start with 25. An additional strike drives the stake 4/5 the distance farther into the ground than the previous strike. So then the next one's 20, then it's 16. And it wants to know what's the total distance to the nearest inch the post will be driven into the ground after 7 strikes. So we have 3 strikes, so we need to get our calculator back going. Do that. And we are going to take that 16, and we're going to multiply it by, make a fraction, control divide, 4/5. That would be 64/5, which we're going to hit control enter to get a decimal. That's what we want. So it's 12.8. So that's our 4th strike. Then we want to take 12.8 times 4/5 again. And we get 10.24. Okay. That's 5 strikes. We want another strike. So times 4/5 again. Get 8.192. And then we have 6. This is the last one. So times 4/5. There it is, 6.55. All right. Now, what we're going to do there, we can just really add these up simply, and that would be fine. However, one of the formulas that you'll have available is this summation formula, which looks like this. This is a sub n times r minus a sub 1 over r minus 1. This is the formula that we can use for this, and I'm going to show how that works. A sub n would be your last term, nth term. A sub 1 is the first term, and r is the pattern. So right here, this 4/5, that's what r is. So if I use that, And type this up, I can make a fraction, control divide. Let's put in our last term, 6.55. Multiply that by our 4/5. That, oops, right there. We're gonna subtract the first term, which is 25. Go to the bottom, and we're gonna do our 4/5 again. We're gonna subtract it from 1. Let's hit enter. And you can see to the nearest whole inch, we get 99 inches adding that. I mean, again, you could just add these one at a time to get that answer, okay? All right, let's look at the next one, transforming logarithms. The idea is almost exactly the same as the transformations we did right here, as far as the shifts go, okay? When I subtract or add from the x value, it's a horizontal shift. When I'm just adding to the function, it's a vertical shift. And when I change it to a negative, it reflects it. So let's look at what we have. Here's the parent function. Right here, when we add to the 2, this is a horizontal shift. And you'll notice that that horizontal shift, when we add, goes to the left. So that's this one here, okay? And then right here, the -4, that is our vertical shift. And since it's a negative, we actually go downward. So that's right there. And that explains what happened on this. So that'd be what you'd want to describe. Let's look at the next one, 14. So we're solving this logarithm. And to do that, we go back to our function here. Let me start. We go with b to the x equals a. And we want to take our logarithm, which this is what we have here. And we want to rewrite it as a exponential. So this is b, this whole thing here is a, and this last part is x. So I'm going to rewrite this as an exponential. E to the 4 equals 4x minus 12. So really all I need to do is I need to figure out what is e to the 4th. So let's look at that. E right here, raise it to the 4th. That is 54.598. I will write most of that. 54.598 is equal to 4x minus 12. So the good thing is this, all we have to do now is just our algebra. So the first thing I'll do is add 12 to both sides. This is going to get me 66.598 equals 4x. And then all I have to do is divide the 4 from both sides. We'll get rid of this. And x is equal to whatever this is. So let's look at that. So 66.598. Divide that by 4. So 16.6495. And look at that. That's what our answer was when we started this. Okay. Continuing, let's go to the next part of this. Next question, number 15. Here we're solving logarithms again. However, we have a little bit different of an approach here because I cannot use this function on number 15. I can't use that conversion. Turning this into an exponential would not work. But we have a simpler method of solving this. It's similar to our thought process on number 7, where we had to get a same base and then cross through them, like here. And all I was trying to do on this question was show that that exponent equaled this one. So if I go to this question, it's a similar idea. I just want to show that this part is equal to this part because everything else about this is the same. So similar to what I did earlier, I can just sort of cross through these. Like I don't really care about those anymore. I just want to see what value of x makes these inside the parentheses equal. So let's solve for x. I'm going to, let's start by adding 2 to both sides. That gets me a x minus 1 over here equals 6x. Let's subtract x from both sides. Negative 1 equals 5x. And then I divide by 5. Goes away and we get our answer, which is negative 1 over 5 equals x, which is what we see right here for the red. Okay. Next, 16. Okay, so this is our properties of exponents. So one of the properties that we talked about was a power to a power. So if we have a base to a value of a and we're raising it to the m, that's the same as saying this right here. when you multiply them. And we saw that on this example here where we had to multiply these. So that property still comes into play here. So we're going to start with that. The first thing that happens is I multiply these. That gets me 2/3 to the, what's 3 times 2? Well, it's 6x. And that's one form that this answer could take. Now, the next thing that happens is this. If I have a power, I'm going to write another rule. If I have a over b to the m, that's the same as saying this, a to the m times b to the m. Essentially, you are taking this m and you're distributing it to their exponents. So we're going to try that. We're going to distribute this to our exponents here. So that gets us, that will get us with both of these to the power of 6x. So this is 2 to the 6x over 3 to the 6x. Okay. And then, so that's another form that this could take. The last thing that we do for our answer here, if we're trying to get to it, 2 to the 6, well, that's where that 64 came into play, and it's still raised to the x. 3 to the 6th is 729, so that's how that got there. Okay, so these are the different forms that this could take. Okay. Got 2 more questions we're going to look at. Number 17, what value of t to the nearest hundredth makes the equation true? Well, in this case, we have an exponential. This looks very much like this question here, how it started, except it's sort of a word question. But we have b, this is x, and this is a. And if I want to solve this, I'm going to have to take it, the b to the x equals a, and convert it into a logarithm. Solve it for that 3t. Just like this question here, the 3 was an issue. We have this 4 as an issue here. So we're going to divide by 4 from both sides. So this is going to get me 10 to the 3t equals, is going to equal whatever 12 divided by 4 is, which is 3. That is 3 right here. Now I'm ready to go. This is b again. This is x, and this is a. Okay, let's change it to a logarithm. So that's going to get us, I'll do that over here. Log base is 10 of 3 equals 3t. So let's grab the calculator. Type that in. Control 10 to the x. We'll put it 10, 3. So that's 0.44 or 0.477. So I'm going to write that right here. 0.477 equals 3t. To solve this, I'm going to divide by 3 on both sides. So we'll get our answer, whatever this is. Let's divide by 3. That is 0.15904 is equal to t. So that's how we'll get our answer on this question. Lastly, we go back to more questions involving the properties of logarithms. That's where we started. That's this little tab right here. So we're using our properties again. In this case, looking at this, it's being multiplied. That is an indicator of the product property. So they're being multiplied, and I want to split them up first. That's how we want to start this. So let's do that. It's going to be log 10 to the 6th. So I move that whole term there, plus log 7 to the 2nd. So that's our product property right here. Then we want to try to use the power property if we can. So we're going to look at these terms. We have a 2 here, we have a 6. So I can take both of those and move them to the front. So that gets me 6 log 10 plus 2 log of 7. And that's how we got our answer there. All right, so this last one here, last question, number 19, we need to condense. And even though these are natural logs, just a reminder that natural log of anything, it's just the same as saying log base e of that value. Okay, so there's not really a big change there. If you prefer to write it like this, go for it. It's fun. So we're going to do the opposite here. We're trying to condense this into a single value. We usually on this one, you want to start with the power properties. We got this 3, we got this 4. We're going to use the power property to take that value, right? That's right here, and move it into the exponent. So I'm going to go back to that one. we're going to take these, we're going to move them into the exponent parts right here. So this is going to be natural log x to the third, subtract natural log y to the fourth. So we just move those powers to the tops. Next, we see a subtraction symbol. We look at we have our rules. We are subtracting. That means it's the quotient property. So we need to take each value and put them into a fraction. Order does matter. So the first number is going to go up top. The second value is going to go on the bottom. So this is how we're going to rewrite this. It will be natural log, we'll put a parentheses, x to the third over y to the fourth. And that's how we get our answer. All right, if you need to go back and review questions that I went over, just rewind, rewatch, and good luck tomorrow.